The James Webb Space Telescope has basically provided the most precise image of Proxima B ever captured, offering remarkable insights into a potentially habitable exoplanet. This discovery invites us on an exciting journey through space to uncover the mysteries of Proxima B and determine if it could be the next Earth, a place we might one day travel to in the vast Proxima cosmos. Proxima B exists in the habitable zone of its star, Proxima Centauri. However, this planet is not typical. Proxima B resides just 4.2 light-years away from us and is shrouded in enigma and wonder. Could it be another Earth, complete with oceans and thriving life? But wait, there's more. Proxima Centauri B isn't alone in its solar system. It also has a companion, Proxima Centauri C, and there could be additional unsolved mysteries within this system that we have yet to uncover. It is remarkable that Proxima Centauri generates roughly the same amount of energy from its star as Earth does from the Sun. Could this genuinely mean that it may have water on its surface, even life? As we venture beyond our own solar system, we encounter a completely new class of planets known as exoplanets. These planets orbit stars with more mass than our own. With 200 billion stars in the universe, the possibilities for exoplanets are endless. Some exoplanets even move freely through space, independent of any cosmic star wanderers. Among them, Proxima Centauri B stands out as a particularly fascinating and alluring planet. It has a year that is only 112 days long on Earth and orbits its star at a distance closer than Earth is to the Sun. In fact, one side of the planet is constantly bathed in sunlight, while the other side remains in perpetual darkness. Now let's take a closer look at Proxima Centauri, the star around which Proxima B orbits. Proxima Centauri is part of the Alpha Centauri triple star system, which includes Alpha Centauri A and Alpha Centauri B. These two stars form a binary system, making them the third brightest stars in the night sky, with a luminosity slightly less than 2.7 times that of our Sun. Proxima Centauri, also called Alpha Centauri C, is a red dwarf star located 4.2 light-years away from Earth. It is the closest star to Earth, and the term Proxima means closest in Latin. Discovered in 1915 by Scottish astronomer Robert Innes, Proxima Centauri is not visible to the naked eye due to its faintness, with an apparent magnitude of 11.13, much dimmer than the human eye's limit of 6.5. Despite being our closest celestial neighbor, Proxima Centauri is still an intriguing star to study. Red dwarfs like Proxima Centauri are highly efficient in energy production, not producing vast amounts of energy but preserving brightness for trillions of years due to their internal convection processes. Proxima Centauri will remain a main sequence star for another 4 trillion years. However, the habitability of red dwarf stars, including Proxima Centauri, is still debated. For instance, Proxima Centauri is a flare star, meaning it experiences frequent and intense bursts of radiation. Additionally, because of its low mass, its habitable zone would be much closer to the star, estimated to range from 0.23 to 54 cents. But Proxima Centauri B's habitability is questionable, as it is frequently bombarded by intense ultraviolet radiation, far stronger than what we experience from our Sun. This radiation is so harsh that even light hydrogen particles are stripped away, along with nitrogen and oxygen. But that's not all. Just because a planet resides within the habitable zone of its star doesn't necessarily mean it can support life. Proxima Centauri B may not even have a stable atmosphere, which is crucial for temperature control and maintaining a water-friendly surface. Without it, any potential life would be vulnerable to extreme space weather, making the planet inhospitable. Although Proxima B may seem Earth-like at first glance, it is far from being suitable for life. Scientists remain cautious, recognizing many factors that could make the planet uninhabitable. The search to uncover the truth about Proxima B continues, and some scientists are still hopeful. One tool that has captured astronomers' attention is the James Webb Space Telescope. After years of anticipation, the telescope was launched in 2018 and is helping us determine if life could exist on Proxima B. However, as with all scientific endeavors, there are challenges to consider. Numerous adjustments were required to guarantee that the James Webb Telescope delivers precise images. As astrophysicist Avi Loeb from Harvard explains, If a planet like Proxima B can absorb light from its star, it can also emit it as infrared radiation. The James Webb Space Telescope was specifically designed to detect infrared light, allowing it to capture images of this radiation from the planet's surface and look for patterns that might indicate water or an atmosphere. But what if the planet has an atmosphere that isn't conducive to life? The presence of an atmosphere doesn't guarantee that life exists, cautions astrophysicist Ed Turner of Princeton University. Proxima Centauri B might have an atmosphere as dense as Venus, which would result in extreme temperatures too harsh for life to thrive. The journey to unravel Proxima B's mysteries is filled with obstacles, and while the James Webb Space Telescope offers a lot of potential, there are additional challenges to consider. With mounting costs, space scientists feel the pressure to find efficient methods of observing planets like Proxima B. But the potential rewards are enormous. Discovering unknown worlds and uncovering the secrets of faraway planets that could harbor life is a pursuit worth following. If Proxima B were indeed habitable, could we one day visit it? It's the closest exoplanet to Earth, which makes it especially intriguing, practically like exploring our own backyard. What makes it even more exciting is that Proxima B is nearly the same size as Earth and lies in the habitable zone of its star, suggesting it could have conditions favorable for life. Its proximity to Earth makes it an ideal target for the search for life beyond our solar system. Though we cannot reach Proxima B just yet, it's certainly on the radar for future missions. As technology develops, investigating this Earth-like exoplanet could one day be within our reach. However, such a journey would be a formidable challenge. For instance, utilizing spacecraft like Voyager 2, it would take 75,000 years to reach the Proxima Centauri system. Nonetheless, an innovative solution has been proposed: solar sails. These ultra-thin sails could be used to propel a spacecraft at unprecedented speeds, potentially cutting down travel time significantly. The future of space exploration is exciting, and Proxima B remains a key candidate in our search for habitable worlds beyond Earth. Spaceships to the Alpha Centauri system and its companion Proxima Centauri use pressure from the Sun to keep the spacecraft on course, eliminating the issue of fuel depletion. What's even more fascinating is that this cutting-edge technology could provide valuable insights into the potential for life on other planets like Proxima. However, as with any ambitious attempt, it has its limitations. The presence of an atmosphere does not automatically imply the presence of life, and Proxima B could end up resembling Venus, with its thick, hostile atmosphere. Moreover, the James Webb Space Telescope can detect infrared emissions from Proxima B if they reach a brightness of just 5% of the daytime side's light. While 5% might seem small, when dealing with a star much dimmer than our Sun, this is quite significant. If Proxima has advanced civilizations, they may use bright orbital mirrors to reflect sunlight from the daytime side to the nighttime side. How cool is that? There are countless exoplanets waiting to be discovered in our universe. These planets come in all shapes and sizes, with some being gas giants of immense size, while others resemble Earth. But what do we know about them? One type of exoplanet that has piqued the interest of space scientists is the gas giant. These planets are similar in composition to Jupiter and Saturn but are much larger. Some of these massive beasts, known as superjupiters, surpass even the largest planet in our solar system. But that's not all. There are also hot Jupiters, gas giants that orbit extremely close to their host star, existing in sweltering conditions with temperatures high enough to melt metal. Imagine seeing one of these planets up close, with its furious storms and dense, churning gases. In addition to hot Jupiters, there are also Neptunian exoplanets, which are similar in size to Uranus and Neptune. These include both standard Neptunes and hot Neptunes, which are smaller and closer to their host stars. Unlike their gas giant cousins, Neptunian planets are often shrouded in mystery, with atmospheres that are difficult to study from a distance. And let's not forget the Earth-like exoplanets, which resemble our own planet. These range in size from smaller than Earth to twice its size. There are even super-Earths, which have masses more than twice that of our planet but are still lighter than Neptune. One of the most captivating exoplanets recently discovered is Proxima Centauri b. This planet, orbiting the star of the same name, is classified as a super-Earth with an estimated mass of 7 Earth masses. Despite its proximity to its host star, it is still too far away to be considered within the habitable zone. Proxima Centauri b isn't alone. It has a companion, Proxima Centauri c, which is significantly further away from its star. This planet has an orbital period of approximately 5 Earth years and was discovered in 2020 using pre-recovery Hubble data. What's even more interesting about Proxima Centauri is that it appears to be an incredibly bright world, possibly due to the presence of a ring system. But there's more to uncover in the Proxima Centauri system. In 2019, astronomers observed a change in the star's orbital speed, which could indicate the presence of another planetary companion. If confirmed, this planet will be called Proxima Centauri d and is expected to be roughly the size of Mercury or Mars. Imagine a universe where the night sky is filled with countless stars and planets, each with its own unique characteristics and orbits. The universe is full of surprises, and exoplanets are just one of them. With new discoveries being made constantly, it's an exciting time to be a space scientist. While we don't yet have an exact count of exoplanets, we do know they exist, just as we know the stars that light up the universe. However, exoplanets come with challenges. They are often hidden by the glare of their host stars, making them difficult to study. Still, advancements in technology have made direct imaging of exoplanets possible. For an exoplanet to be directly imaged, it must be 1. Large enough to be seen by telescopes, 2. Far enough from its host star to avoid being obscured, and 3. Young enough to be hot and visible from Earth. These restrictions limit the number of exoplanets that can be directly observed, but they provide a fascinating glimpse into the attributes and composition of these distant worlds. Exoplanets are most commonly found by the effects they have on their host stars. The gravitational pull of an exoplanet can cause its star to wobble, and this can be detected using the radial velocity method. Astronomers using the Kepler Space Telescope employed the transit method, which measures the dimming of a star's light when an exoplanet passes in front of it. This method has given us valuable information about exoplanets, including their size, distance, and temperature. Here are a couple of fun facts. More than 22% of Sun-like stars have Earth-sized planets in their habitable zones. The TRAPPIST-1 system is home to 7 exoplanets with rocky terrain and potential water on their surfaces. Exoplanets can also have natural satellites, known as exomoons. With more than 4,000 exoplanets discovered so far, we know they exist in abundance throughout the universe. Hot Jupiters, with their massive size and rapid rotation, are the easiest to detect, but countless other exoplanets remain undiscovered. Now, NASA's James Webb Space Telescope is unveiling the secrets of the universe, one discovery at a time. This extraordinary telescope has been gathering data and capturing stunning views of space, revealing previously unknown wonders. Recently, NASA made a groundbreaking announcement. The James Webb Space Telescope has found the first definitive evidence of carbon dioxide in the atmosphere of a planet outside our solar system. This discovery provides crucial insights into the planet's composition and formation, offering us a glimpse into the mysteries of the universe. The gas giant in question orbits a Sun-like star 700 light-years away. This finding marks a significant step forward in the search for extraterrestrial life. NASA Administrator Bill Nelson stated that this discovery would provide us with a new perspective on the universe that we've never seen before, sparking excitement among astronomers and scientists worldwide. But that's not all. The James Webb Space Telescope has also been capturing breathtaking images and gathering data in the infrared spectrum. One of its observations includes the young stellar object known as 110 IRS-4. The light from this object illuminates cool, wispy cloud material, while orange spots behind the cloud reveal light from distant stars obscured by ice. This remarkable research is part of Webb's Ice Age project, which aims to study the formation of ice from its creation to its development into ice comets. And that's still not all. The James Webb Space Telescope has imaged the inner workings of a dusty disk surrounding a nearby